Here we are at 9a from our target 5. We're asked to go ahead and solve for x. Now, in just looking at this, we do notice that we have a compound inequality because there's multiple pieces. We have the left side, the middle, and the right side. We are talking about an AND statement. And anytime we see that, our graph should look something where maybe if we have two sides, it doesn't matter if it's open or closed for right now, but they should be going inward towards one another. All right, so this is roughly the shape of the graph we'll see. Well, going ahead and starting by solving this, our end game is to try to get x in the middle all by himself. So it's very much just like when we're solving an equation. This -10 really has nothing to do with the x. We'll go ahead and add it, but we'll add it to all three sides instead of just two like an equation. Now on the left side, when we add this, we have 4 plus 10, that comes out to be 14, is less than, because we see the less than symbol, 7x. The -10 ends up canceling with the positive 10. Then we have this less than or equal to symbol, and then 11 plus 10 comes out to be 21. Now all we have to do is go ahead and still try and get the x by itself in the middle. It has this coefficient 7, so we'll divide 7 on all three sides. In the middle it cancels. On the left side, 14 divided by 7 comes out to be 2. X again is in the middle. It's less than or equal to 21 divided by 7 comes out to be 3. So there we've gone ahead and solved for x. Now let's go ahead and graph this thing. Well, when we graph it, here is roughly our number line. We have 0 over here, and we notice that 2 is to the right of it, and 3 is also to the right of it. Now around 2, x has to be larger than 2. So right here, we see that we have an open circle around 2. And then when we test and shade, well, we have a test of 0. So is 2 smaller than 0? Is this true or false? Well, this is definitely false. 2 is not smaller than 0. So on this side, we would have our false statement because it was looking at 0. Well, 0 didn't work out. So that means that the right side must be true. And so we would normally go this way. Now looking over at x being smaller than or equal to 3. We do notice that we have a little hole around 3, and it is filled in because x can actually be 3. It's got that less than or equal to symbol. Then just like before in the blue, we're going to go ahead and test 0. Is 0 less than or equal to 3? Is that true or false? Well, that is absolutely true. And so because 0 is on the left side of 3 and it was true, the other side, had we picked a different number on the right side of the 3, would have been false. You can kind of verify that with yourself. Like you can check 10 if you really want. It'd be a false statement, so anything bigger than 3 is false. So we pretty much just, again, shade towards the truth. And in just looking at our graph, it would be this region in between. Now looking at the interval notation, that's the last part. Our interval notation. The smallest thing that x can be here is 2. But since it can't quite be it, it can come crazy close to 2. We have that parenthesis around it. And then 2 is going on and on. I'm sorry, x is going on and on and on until it reaches 3. And then 3 cuts it off. But it can be 3 because we have that solid filled in circle. And again, because x is less than or equal to 3. So then we would have a bracket. So that would be our interval notation. Again, though, that is problem 9a from our target 5.